Hi, I'm going to talk about direction angles of vectors. You put the vectors in standard position and you measure the angle it makes with the positive x-axis. So for this vector, it's this positive angle and it's this obtuse positive angle for this vector pointing into the second quadrant. For vectors in the fourth and the third and fourth quadrants, the direction angles would be negative. So you measure this direction. Okay. An example. Let's find the direction angle of this vector. It's named u vector and has x coordinate 2 and y coordinate 1. So it's this positive angle here. The length of u is the square root of 2 squared plus 1 squared, so it's the square root of 5. So this length is square root of 5. That means that this length is root 5 cosine theta, and this height is root 5 sine theta. And this length is 2, and this length is 1. That means I can take the quotient, root 5 sine theta divided by root 5 cosine theta, and shorten this, equals 1 divided by 2. However, this is tan theta, so I can find the tangent to be 1/2, and using my calculator, I'll put it in degree mode and take tan inverse of 0.5. That would be 26.6 degrees. So approximately 26.6 degrees. Let's look at another example. I've made this vector u, x coordinate -1 and y coordinate 2. Still, the length of u is root 5. So if it's in standard position, then the terminal point will lie on a circle of radius root 5 about the origin. So the coordinates of the terminal point would still be root 5 cosine theta and root 5 sine theta. So taking the quotient, we'll get tan theta to be the quotient of this, so -2. That's tan theta. However, if I use inverse tan on -2, I'd get this angle, because tan inverse gives me an angle between -π12 and π12. So I would have to add another 180 degrees in order to get this one. And I know that I want a point in the second quadrant because I have a negative x coordinate and a positive y coordinate. So I know exactly where the terminal point is going to be. So theta would be tan inverse of -2 plus 180 degrees. So approximately tan inverse of -2 plus 180, 117 degrees.